Section 2.4 is solving equations with variables on both sides. I can solve equations with variables on both sides, and I can identify equations that are identities or have no solution. Big ideas here. Equivalent equations are equations that have the same solution or solutions. The solution of an equation with variables on both sides can be found using the properties of equality and inverse operations to form a series of simpler equations. And the properties of equality can be used repeatedly to isolate the variable. To solve equations with variables on both sides, we can use the properties of equality and inverse operations to write a series of simpler equivalent equations. So, if we look at example 1 here, I have a simplified expression on my left side and a simplified expression on my right side. There's nothing else I can do to those two expressions. So I'm going to have to get all my variables together by crossing my equal sign, doing the opposite. Here I'm going to pick the smaller of my two x values. Just gives me less negatives to work with. So since 2 is smaller than 5, I'm going to get rid of my 2x. Right now I have a positive 2x, so to get it to 0, we subtract 2. To get rid of a positive, we take a minus. 2 minus 2 is 0, whether it's got the x on there or not. Anything and its opposite always add to 0. And whatever I do to one side, I do to both. And here I can combine that, we subtracted. I can combine that with my 5x because they're like terms. So 5 minus 2 gives me just 3. And those are still x's. We bring down the rest of the problem that we haven't changed yet. And now, once we get to here, it's the same as we've been doing since section 2.2. To get x by itself, first I'm going to subtract to get rid of my addition, and whatever I do to one side, I've got to do to both. Just like up here, whatever I did to one side, I did to both. My variable is being multiplied by 3. I get rid of multiplication by dividing, and I get x equals 4. To plug it in and check here, I take 5 times 4 plus 2 and set it equal to 2 times 4 plus 14 and check, are these the same? 22 on the left, 22 on the right, they are the same, so x equals 4 is our solution. Now, feel free to pause here and give this a try if you'd like. Again, my left expression is as simple as I can get it, and so is my right expression. So now I need to try and get all my variables together on one side. I want just one k here. In order to get it isolated, we have to have them all together. I'm going to move my 4 because it's smaller than 7. So I'm going to subtract 4 to get it to be 0. If I have 4k, I take away 4k. That's how I get it to 0. And whatever I do to one side, I have got to do to both. 7 minus 4 is 3, and I keep that k there. And I can put these together because they have the same variable part. They are like terms. We bring down the rest of our problem. Don't forget that negative goes with the 10. Right now, left side's as simple as I can get it, right side's as simple as I can get it. All my variables are together. So we moved our variables to the left. I'm going to move all my constants to the right. To get rid of a 2, I subtract 2. 2 minus 2 gets me to 0. Same signs, add them up, give the common sign. So I've got all my variables on one side, all my constants on the other. That's perfect because now to get k by itself, I have multiplication. I can go ahead and divide. And I get k equals negative 4. We can plug it back in and check. And here we will get negative 26 on both sides. It takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? So we're comparing how he does it now compared to the new software. And we're going to see when they'd be the same so that we know when one would be better than the others. Well, right now it takes 1.5 hours to make one page. So it's 1.5 hours times the number of pages. The new way, each page is 1.25 hours. So 1.25 hours times the number of pages, but it takes 8 hours to learn the software. That's an additional 8, and that's not per page, that's just a one-time training thing. So here, I'm going to move all my variables to one side. Since the only thing I have on the left is my variable, I'm going to move to the left with my variables. Also, my 1.25 is smaller. So anything minus itself gives me 0. Here I get 0.25, p equals 8. 8 is being multiplied, so we get rid of it by dividing. Sorry, p is being multiplied, so we get rid of it by dividing. And I get 32. So 32 pages is when it's going to be even. So in order for the second one to be better, to save time, the person would have to make more than 32 pages in order for it to be save time with the new software. That could be 33 pages, that could be 100 pages, that could be 32.25 pages. Anything more than 32 pages is going to make the new software better. If it's exactly 32 pages, then it doesn't matter which way the designer uses. It's going to be the same amount of time either way. Now, feel free to pause here and give this a try. An office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. In how many months will the copier pay for itself? So here, we're comparing the new copier to the old copier. And we want to see when will they be the same, because in order for it to pay for itself, the cost has to be, the difference in them has to be the same. Okay, so they have to equal each other. An energy-saving copier is new. That costs $650 for the copier itself. Now, the monthly electric bill with the new copier is reduced to $88 per month. That's $88 times the number of months. And we're looking for how many months, so m is going to be my variable here. The old ways, it used to be $112 per month, so times the number of months. And that how much was paid for the old machine. It was $112 each month. The new machine is $88 each month, so times the number of months, but it costs $650 to buy the machine. Now, we're going to get all of our variables together on one side. And again, anytime we cross over the equals, we're going to the opposite side from the left to the right or the right to the left. We have to do the opposite operation. So 88 minus 88 is how I get to 0, and whatever I do to one side, I have got to do to both. So here I get 24 months. To get m by itself, I have multiplication, I divide. And when I do that, my number of months is going to be 27.083 repeating. But we only get our bills every month. So if it's only 27 months, then we have this little bit here that's still not paid for. So we're going to say after 28 months. It'll take 28 months for it to be completely paid for. And then it will have saved a little bit of money. But again, we only get our bills once a month, monthly. So this last little bit won't be paid off in the 27th month. It's not until the 28th month, until the next month. Example 3 here, we want to find our solution. And just like we did in section 2.3, both sides have to be simplified before we can move from one side to the other. So I am not simplified on either side here. I have parentheses. I have to get rid of those. And I do that by distributing. I take that multiplication to both pieces. So 2 times 5x and 2 times negative 1 gives me 10x minus 2. I take the 3 times x and the 3 times 11, and I get 3x plus 33. Now, my left side is as simple as I can get it. My right side is as simple as I can get it. Do a quick check here to make sure everything changed. I used to have a 5x and a 1, now I have a 10x and a 2. I used to have an x and an 11 in my parentheses, I have a 3x and a 33. So they both changed. So we know we at least distributed. We might have multiplied wrong or something like that, but for now we know we at least put it to both pieces. I can't combine any like terms on my left or right side, so now I can finally start moving from one side to the other. Left side is as simple as I can get it, and so is the right. First thing I'm going to do is get my variables together, and if I look, 3 is smaller than 10. Right now I have a positive 3, so I'm going to subtract 3 to get that to be 0. I have 3 x's, I'm going to take them away so that I don't have any left on my right side. And whatever I do to one side, I have got to do to both. Now, my x is being subtracted and multiplied. We get rid of our subtraction first using that backwards PEMDAS. X is being multiplied by 7, so I'm going to divide by 7 and get x equals 5. If we plug it back in, I'm going to get 48 equals 48, and it does check. Now, feel free to pause here and give this a try if you'd like. Before we can solve here, I need to have both sides as simple as I can get them. Both expressions have to be simplified. On the left, I have parentheses, so I'm going to distribute to get rid of that. 4 times 2y, and then I'm going to take 4 times 1. 8y plus 4. Again, both pieces have changed, so I distributed to both. On the right side, I have parentheses as well, so I'm going to go ahead and distribute here. I'm multiplying by 2, so I'm going to multiply each piece by 2. Don't forget to take the sign with that number. So I get 2y minus 26. I used to have a y, now I have a 2y. 13 became 26. So both pieces were distributed. I'm going to get my, since my left side is as simple as I can get it and my right side is as simple as I can get it, I can go ahead and get all my variables together on one side. I'm going to move variables from my right side to my left side because 2 is smaller than 8. Right now it's a positive 2, so to move it, I subtract. I have 2 y's, I take them away to get to 0. Bring down what's left. And again, I can combine that with my 8y because those are like terms. 8 minus 2 gives me 6y, and we bring down what's left. My y is being added and multiplied, so I'm going to subtract first. 4 minus 4 gets me to 0. And now to get my y by itself, I get rid of that multiplication. And again, we use those backwards PEMDAS steps, and we get negative 5. If we plug that back in, that will check. Same idea here. We're going to simplify our left and right expressions. Distribute. 7 times 4 gives me 28. 7 times negative a gives me negative 7a. 3 times a gives me 3a. And 3 times negative 4, remember take those signs with your numbers, gives me a negative 12. Now I'm going to get all my variables together on one side because both sides are as simple as I can get them. Here, negative 7 is actually smaller, so I'm going to add 7a to get to 0. It's like I owed somebody 7 and then I gave them 7. We're even. 28 equals 10a minus 12. Get rid of any subtraction or addition first by doing the opposite. Negative 12 plus 12 gets me to 0, and that's perfect because 0 plus 10a is just 10a. I have multiplication. I get rid of it by dividing. And a equals 4. And if I plug it back in here, this is going to check. If you would have subtracted the 3 instead of adding the 7, you'd still get to the same spot, but we would have had a lot more negatives along the way. So we have to be careful there when we're adding, subtracting, dividing, just even rewriting the problem. The more negatives we have, the more likely we are to accidentally make a mistake. So it's a little bit easier to work with positive values there, so I always move this smaller. And I look, negative 7 versus 3, negative 7 is smaller. I'm going to pause here and continue on in another video.